Yes, good evening, students. This is Ramesh Reddy. Welcome to Chemistry Academy. Today we are going to discuss the live classes, Group 3 elements. Group 3 elements. Inorganic chemistry. Group 3 elements. Now see the group 3 elements. So what is group 3 elements? Generally, if valence electrons enter into the p orbitals, known as p block elements. So in p orbital, maximum how many electrons? Maximum 6 electrons. That starts from p1 to p6 configuration. Now if it is p1 configuration, that elements named as group 3 elements, G3 elements. Now we go to discuss group 3 elements. Now what are the group 3 elements? Yes, what are the group 3 elements? Boron, Aluminium, Gallium, Indium and Thallium. Group 3 elements are Boron, Aluminium, Gallium, Indium and Thallium. These are group 3 elements. Now, see the element, its atomic number. Next, go to electronic configuration. See the element, atomic number, electronic configuration. Now, what are the elements? Boron, Aluminium, Gallium, Indium and Thallium. Now its electronic configuration with noble gas configuration. Helium, that is neon, argon, krypton, helium, neon, argon, krypton. Next, xenon and radon. Now we need up to xenon. So what is the general electronic configuration? General electronic configuration is NS2 NP1 configuration. NS2 NP1. Now we'll go to first one, boron. Total how many? 3 electrons. So 1s2, 2 electrons completed. Next 3s2, 3p1. Next neon, 4s2, 4p1 configuration. What about next one? Next one here starts with, see here, this is S block elements. Next after that, P block elements, S, P. Next starts with D block elements. Now here see the D block elements, zinc, cadmium, mercury. So extra 10 electrons. Here also extra 10 electrons. Here 10 plus 14 electrons. Extra 10 plus 14 electrons. Now here see the configuration. 3d10. This is 3s2. Written small correction. 3s2, 3p1. 3d10. Next 4s2, 4p1. Next one 4d10, 5s2, 5p1 configuration. Next here 5d10, 6s, 5d10, 4f14, 6s2, 6p1 configuration. 6p1. See here, presence of what is that? Extra d10 electrons. Next here, presence of extra 14 electrons due to d10, f14. So these elements shows inert pair effect. Inert pair effect. What is inert pair effect? Due to electron density. Due to electron density in valence shell, attraction increases. Therefore, size decreases. So that effect is known as inert pair effect or transition effect. Also known as transition effect. Now go to atomic number. So generally noble gas atomic number add +3. For third group add +3. For fourth group add +4. Otherwise noble gas add 2, 10, 18. Now what is this? Total how many? 5 electrons. So atomic number how much? 5. Next aluminium 13. What about gallium? 31. Next to 49. Next to 81. 5, 13, 31, 49, 81. These are the atomic numbers. Now, what are the third group elements? If valence electrons are entered into the p orbitals, again p orbitals divided into 6. Now, in that first one is third group elements. Third group elements are boron, aluminium, gallium, indium, and thallium. Next, go to element, its atomic number, and general electronic configuration. Now, boron, aluminium, gallium, indium, thallium. Next with its electronic configuration. Electronic configuration. See here extra what is that? D10 electrons and extra F14 electrons. So due to these D and F14 electron shows what is that? Inert pair effect or transition effect. Inert pair effect or transition effect. So copy this one. Yes, next go to general properties. General properties of third group elements. General properties of third group elements. Now, what is the first property? First property, abundance. Abundance means availability. So, which is more available? So, in this case, aluminium is more available. Aluminium is more available. Now, aluminium, boron, aluminium, gallium. Next, indium and thallium. So, which is more available? Aluminium is more available. Next, go to general electronic configuration. Electronic configuration. So, third group elements. So, number of valence electrons is equal to how many? 3 valence electrons. Now, general electronic configuration NS2 NP1. So, number of valence electrons is equal to 3. Number of valence electrons is equal to 3. Go to next property. Atomic radius. Atomic radius. What is atomic radius? Atomic radius means the distance between center of the nucleus to outermost shell of an electron, or probability to find an electron. So that distance is known as atomic radius. So generally in periodic table top to bottom atomic radius increases. So atomic radius increases. Here also top to bottom atomic radius increases due to D and F transition effect. F transition effect. See the order. First boron, Next, aluminium. After that, gallium. Next, indium and thallium. So boron to gallium. See here, compared to gallium and aluminium, very less. Next, indium and thallium. Aluminium to gallium increases, but here aluminium is more. Aluminium is more due to D10, D transition effect. Radius is decreases. Then aluminium, that is inner pair effect. Here also decreases, but almost equal to Indian. So this is the order follows exception. Reason is due to inert pair effect or transition effect. D and F transition effect. Next, go to next property. Ionization energy or ionization potential. Ionization energy or ionization potential. What is ionization energy? For example, this is the nucleus. Next, outermost electron. Removal of outermost electron from isolated gaseous atom. So requiring some energy. That energy is known as ionization energy. So what is the simplest one? Removal of electron requiring some energy. That energy is known as ionization energy. Next, ionization energy and atomic radius both are inversely proportional. If size increases, electron attraction decreases. Therefore, require less energy for removal. So, atomic radius and ionization potential both are inversely proportional. Now, see the order. See the order opposite to this order. So, boron maximum. Next to gallium. Next to aluminium. Next to indium, thallium, and indium. This is the order. Again, some books they will given boron, thallium, after that gallium, next to aluminium, and indium order. So both are correct. So according to NCERT, first one is correct. Boron, aluminium, gallium, indium, and thallium. Due to inert pair effect. Due to inert pair effect. This is ionization energy. Next, go to electronegativity. Electronegativity. So generally, top to bottom, electronegativity decreases, but here increases little bit. So boron, aluminium, gallium, indium, and thallium. Then boron shows maximum electronegativity. So boron shows maximum electronegativity, more electronegativity. So this is more electronegative. Due to electronegativity, it shows only -3 oxidation state is more stable, but +3 oxidation state is very less available. So very less stable, very less available. Go to next one. Next, density. Go to density. So generally, top to bottom density increases. Top to bottom density increases. So boron to aluminium, next to gallium, next to indium, and thallium. Here there is no exception. Top to bottom density increases. Next, go to melting point. Boron shows highest melting point, and gallium shows lowest melting point. Boron, next aluminium, next indium, and thallium. This is the order. Boron shows highest. Boron shows more or highest melting point. highest melting point. Reason is it is in the form of B12 structure. That structure is called joint structure. Joint structure. So in this case, 20 phases is related to solid state. 20 phases and 12 carbons. So the structure contains, in three-dimensional network structure contains 20 phases and 12 carbons. Next, gallium. Gallium shows less melting point. Less melting point. That is approximately 30 degrees Celsius. So this is in the form of Ga2, gallium 2 discrete structure. Discrete structure. Gallium 2 discrete structure. Discrete structure. Now, due to, see here, gallium shows 30 degrees is the melting point. Almost boiling point is 2200 and nearly 2230 or 40. So 30 degrees Celsius is the melting point, but boiling point is how much? 2200. 2200 due to high difference. Due to this high difference, it is used in thermometers. Used in thermometers for finding temperatures. For finding temperature. Next, gallium also known as summer liquid. Summer liquid due to high boiling point. Known as summer liquid due to high boiling point. This is the order of melting points. So which is more? Boron shows maximum melting point. Gallium shows less melting point. Follows exception. See here, atomic radius, ionization energy, electronegativity. Next to melting point. All are follows exception. Next go to boiling point. So there is no exception. Boron, aluminium, gallium, indium, and thallium. Top to bottom, boiling point decreases if there is no exception. Top to bottom decreases. Yes, copy it. Go to next one. Next property, oxidation state. Oxidation state. So generally oxidation state is equal to group number. So general oxidation state shows +3 oxidation state +3. Now what is the electronic configuration? NS2 NP2. NS2 NP2 electronic configuration. NS2 NP1 third group. NS2 NP1 configuration. So it shows +1 oxidation state and +3 oxidation state. +1 means loss of one electron. That is from which orbitals? NP orbitals. If loss of electron from only p orbital shows +1 oxidation state. +3 loss of electrons from s orbital and p orbitals. That is from ns orbital and np orbital. So in this case only p means remaining electrons are stable electrons. So we cannot remove s2 electron. That is by what is that? Inert pair effect. Inert pair effect. Due to inert pair effect, only removal of p electrons shows +1. Anyway, generally shows +1 and +3 oxidation state. Next. Now compared to +1 and +3 stability. So top to bottom, +1 oxidation state. +1 oxidation state increases, but +3 oxidation state decreases. +1 oxidation state increases, +3 decreases. Same by, what is the reason? Inert pair effect. Inert pair effect or transition effect. Inert pair effect or transition effect. Now go to first one, boron. Boron shows generally +3, but +3 is unstable. Due to more electronegativity of boron atom shows -3 oxidation state. So -3 is stable. Reason due to more electronegativity of boron. So for example, B-3 ions. Example, Mg3B2. Mg3B2. So it is a magnesium shows positive, boron shows negative. That is -3 oxidation state. Next, go to thallium. Thallium shows +1 oxidation state and +3 oxidation state. So which is more stable? Thallium +1 state is more stable. +1 state is more stable. So now from top to bottom, go to aluminium, gallium, indium, and thallium. So aluminium +3, gallium +3, indium +3, and thallium +3. So which is more stable? Aluminium is more stable. +3 state is more stable. Next go to +1. So aluminium +1. Next gallium +1. Indium +1. Next thallium +1. So which is more stable? Thallium +1 is more stable. More stable. Now see here, loss of electrons decreases. Therefore, reducing power also decreases. Means loss of electron means reduction. Reduction means oxidizing nature. Next, in any reaction, thallium +3 is formed by taking one electron converted to thallium +1 oxidation state. Reason is compared to +3, +1 is more stable. Due to stability, so it gains 2 electrons. Go to next. Covalency. Next property. Covalency. Covalency. What is covalency? Minimum or maximum? Maximum bonds with surrounded atoms. That is called covalency. Now go to third group elements. Boron. Boron shows maximum covalency. Maximum covalency 4. But valence electrons only 3. Shows 4 bonds. See the reason? So atomic number 5. Electronic configuration 1s2, 2s2, 2p1. First one is stable. Next, 2 electrons present in s orbital. 1 electron present in p orbital. If electron jumps to p shell, now how many? 3 valence electrons. One is s orbital, remaining 2 is p orbital. Now this electron shows 1 covalent bond. Second one shows second covalent bond. Third one shows third covalent bond. But this empty shows day 2 bond. Day 2 bond. Empty orbital forms day 2 bond. See the example. For example, BF3. In BF3, boron, how many valence electrons? 3 valence electrons. And shared with 3 fluorine atoms. So it is the BF3 molecule. Number of bonds is equal to 3. Next, in BF3, boron, presence of vacant orbitals. Next, F minus, this lone pair donated to vacant. Then to form BF4 minus. BF4 minus. So now what is surrounded atoms? 4 surrounded atoms. Now what is the covalency? Maximum bonds is equal to how many? Maximum bonds is equal to 4. So therefore covalency is equal to 4. Boron shows maximum covalency 4. More than 4 not possible. More than 4 covalency not possible. Reason is there is no d orbitals. But in aluminium, Aluminium shows covalency is equal to 4 and more than 4 also 4 possible. So that is maximum covalency 6. Reason is presence of vacant d orbitals. Due to presence of vacant d orbitals, aluminium forms maximum covalency 6. For example, Al, generally Cl3, Cl3 is clear or not? AlCl3.